this demo on horizontal pod auto scaling. I call it as HPA on OpenShift, Red Hat OpenShift platform. Okay, so for those of you who don't know, Red Hat OpenShift is a container platform, container orchestration platform built on top of Kubernetes for enterprises. So you can use it on cloud or on-premise. So in order to deploy your cloud native applications on any of the platforms or on any of these application stacks or the technologies into this container platform to make a highly scalable application availability or high availability OpenShift cluster. Okay, so in order to show this demo, basically, these are the 6 steps I'm going to follow. Basically, I'm going to use in an OpenShift Sandbox environment that is kind of provided by Red Hat in this demo. Anybody can, can get provision. We'll see it in a moment. So we'll use that environment to kind of demo. And secondly, we will use a publicly available Java Spring Boot application with the MySQL database as a sample application to deploy into this platform. Thirdly, I will show the exact horizontal pod auto scaling HPA settings that you need to do in order to kind of do configure. You can do it through UI as well as through the command prompt, but I will show it on the UI to keep it simple. Okay. So once all these configurations are in place in OpenShift, then you need to really trigger that condition, right? So for that, you need some sort of a load testing tool like JMeter or LoadRunner or NeoLoad, or in this my example, I'm going to use Apache Benchmarking tool, which is a lightweight command line benchmarking load testing tool in order to really simulate condition the load on my application endpoint. And then that should trigger in step 5 the horizontal auto scaling based on the CPU usage limits that I set in step number 3. Okay, so we should see that in action. So that's the step number 5. And finally, we will conclude this demo by analyzing the results and really understanding the magic of HPA and what benefit it can bring to your end users of your application and also to your organization in terms of cost savings, either it be cloud or on the on-premise infrastructure. Okay, so without further delay, let me start with So this is the Red Hat site. This is the developer sandbox environment. This is the URL where you can go and request for the sandbox environment. So they give you for 2 weeks, and every 8 hours, the pods will be restarted. It has about 15 GB of storage and 7 GB of hard disk, 7 GB of RAM. So in order to deploy your application, these are simple steps. You don't have to give your credit card or anything like that. You just need to give your phone number, and within seconds you will be up and running with this platform. You don't have to go through the entire installation of Kubernetes cluster and provisioning the infrastructure, and all that thing has been already done. So this is basically a OpenShift dedicated environment that is available to you. But while I say dedicated, it is basically the multi-tenant OpenShift cluster. So it's basically there are 2 or 3 namespaces that get created and dedicated for you, which is secure for deploying your applications. At the same time, the entire container platform is basically like a SaaS environment. It is shared between multiple tenants. So that's why I said multi-tenant application hosting platform. Okay, but it's good enough for the demo. So I'm going to use this. I already have got provisioned an environment here for the demo purpose. Okay, so now we will quickly see the sample application that we are going to use in this application, use in this demo. Okay, so this is the Spring Pet Clinic. If you're familiar with the Spring Boot applications, this is the Spring Pet Clinic application, which is a Java based and then Java Spring Boot and MySQL database in the backend. Okay, and this is a public repo that is available in GitHub. And then how to basically deploy this application into OpenShift. The steps are actually in the README in GitHub. I'll not spend much time there. You can go through this and self-help and get enabled there. Okay, so now we will see this sample application and also the container, the sandbox that I have set up. So this is the sandbox environment where I have set up, and then this is where this is my application topology, where I have this MySQL database, and also I have this Java application pod. So there's one pod for database and one pod for the application. Okay, so this is my application. So I just click on open URL, and this is publicly available application now on the it is hosted, and it is routings are set to be publicly available. So this is the landing page, and then I click on find owners. This is the use case that I'm going to go through for the purpose of the demo. And then I don't give anything blank, and then I just click on find owner. So this will query the database in the backend, and then it will pull all the records that are out there, not much, but and bring it up in the screen. So this is the kind of endpoint that I'm going to hit eventually using the load test tool. Okay, we'll see. So coming back to OpenShift, so all my deployment configuration is done. So now I need to do the horizontal pod auto scaling here, right? So how do I do that configuration? So I can go here and I can say add horizontal pod auto scaler. In my case, I already have this configuration, so it is showing me edit. Okay, before that, I'll have to go and edit my application. Okay, so application configuration, and why I will tell you in a minute. So I say this is edit Spring Pet Clinic, which is my application. Okay, Okay. So here there is something called as the advanced settings, and there's something called as resource limits. So this resource limit by default, there's no limit. I mean, it can take any capacity on the that is available on the OpenShift cluster. Okay, but in order to set the horizontal pod auto scaling, I need to limit my resources, right? So I'm going to do the scaling based on CPU usage. Okay, so that's why I'm going to set this limit for CPU. So I'm saying that you can request for 200 millicores at a time, and then your total limit is going to be 2 cores. Okay, the maximum that you can get for this application. And similarly, you can do the settings for memory utilization as well. But as of now, in version 4.6 of OpenShift, which I am currently using, memory utilization is still in technology preview, and it's not general availability is not there. So I'm going to leave it blank for now. Okay. So since I've already done the settings, okay, I'm going to hit cancel. Otherwise, I have to make those settings and click on save. So once I have set this resource limit when I'm deploying the application, okay, so I can it is kind of a prerequisite for me to do the horizontal pod auto scaling settings. Okay, and just wait for the topology to come back. Yep, it's back. So I select the application, and then I go to actions, and then I say add horizontal pod autoscaler or edit horizontal pod autoscaler. Okay. So once I come here, I see this warning, but I can ignore this. What this is saying, this is just a warning. What it's saying is, the memory resource limits are not being set. That's what it's telling. But as long as CPU is set, that's fine. So I'm going to work with CPU usage. Okay. So I can do these configurations using the command line also, using the OpenShift endpoint, or I can also, do through any YAML file here, or I can do it just simple on the UI. So for now, for the demo purpose, I'm going to do it on the form, very, very simple using the UI. Okay. Not even the YAML. So I give a name to my horizontal pod settings, HPA settings. Okay, anything, you can give anything, and then by default you have minimum 1 pod, and then maximum of 3 pods. You can change these things, the values here. Okay, but for now I will keep it as 1 and 3 to keep it simple. And then here is where you will say the CPU utilization based on the resource limits that you provided for the CPU. You are going to set a limit here, right? You can say 50% or 70% or 20% or 30% whatsoever. So for now I put 20%. That means whenever the first pod kind of reaches the 20% threshold, that's when the second and third pod should start horizontally scaling. Okay, whenever that load is making the first pod greater than 20%, that's when the other 2 pods will start scaling. Okay, that's what it means here. Okay, since I've already set it, so I just click on cancel. So at this point, I am done with my horizontal pod auto scaling settings. Okay, but by default there is no load, right? So without the load, it is just waiting there with 1 pod at a time, right? So in order to scale this, it needs the load. Okay, so in order to create the load, as I mentioned earlier, I have used Apache Bench tool. Okay, so this is my Linux instance that is basically on the AWS EC2 instance. I have installed Linux. Okay, and I have configured Linux, sorry, and then I have this Apache Bench tool that is installed on this Linux instance. Okay, so in order to verify whether it is available, so I just say run this command abb, and then I see that yep, it is available. This is free and open source, which I'm going to use. So now I'm going to run this one line command, which will actually trigger a 10,000 requests with 100 concurrency against this endpoint of the application, which will actually create the load. Okay, so this endpoint of the this URL of the endpoint that I'm giving here is the same as what I see here. Bear with me. Yeah, so it's the same endpoint of this application that I'm trying to access this page with 100 users concurrent load, and I'm going to do this for 10,000 requests. Okay, so when I just hit enter here, that's what is going to happen. Okay, the load test is going to get triggered. So let me do that. Okay, so now the requests should start getting triggered. Yep. So there are 10,000 requests, 10% of the requests, like 1,000 requests have gone through, and now it goes to 2,000. Yeah, it goes on increasing, right? So meanwhile, let us see what is happening on the OpenShift app. As you see here, as the load increases, you can see that it already crossed the 20% CPU usage, and 2 other pods get started spinning, and then the application build is getting deployed into that. So whenever that is dark blue, that means the like you see in the database pod here, right? It is in steady state. Whenever it is light blue, that means it is not ready yet, and it is spinning, and the application is getting deployed into these pods. Okay, so now the second pod is ready. Yeah, now the third pod is ready. So this is a visual representation, the beauty of the horizontal auto scaling that is happening, pod auto scaling that is happening under the load conditions. So now let's go back to the test. Okay, so the test has finished now. So if I go here, so all the 10,000 requests are completed, and this is the endpoint document path, and this concurrency is 100, and the time taken for test is 66.2 seconds, and there was no any failed requests, and this is the throughput, and this is the request per second, and the time per request is 6.6 milliseconds, averaged out across 100 concurrent requests. Okay, so this is complete now. So now if I go ahead and hit once again, when all the 3 pods are already available, the response is going to be even faster. Okay, because now there are 3 pods, so it's going to be at least 3 times faster, or 300% times faster now, because the application is scaled and it is ready. It is in a state ready to take higher load. Okay, so it doesn't again spin any additional pods or anything like that. It's already in the highly scaled state now. Okay, so in this case I was able to complete within 31 seconds that the whole test. It's almost less than one third probably, and then the time per request is about 3 milliseconds. Okay, let us not worry much about the stat. We will revisit this later and do a benchmarking or comparison across. Before that, when now there is no load on the application, right? So as the load of the application goes down, these pods will again scale back to 1. Okay, in order to conserve the resources. So, but there is a threshold time for which it will keep waiting. It may get a load, and once it is sure that the threshold is crossed and it is not getting any further load, then it will start auto scaling back. Okay, before that happens, let us quickly go and see the monitoring stats here on OpenShift. So this is the Prometheus charts that you see here. So you can see that the CPU usage of the first pod got above 0.2%, the 20% for 20% or 0.2 here, and that's when the other 2 pods started spinning. And this is the last one is the database. There's no much load on the database, which is blue, while the other things are showing the pods, right? And you can see that, and the memory usage of the pods is also visible here, how it shoots up under load conditions. Okay, so these are other stats here, and we can see that there was no any packet drop or anything due to the load. There was no any outage in the network or anything like that, so 0 loss of packets. Okay, so exact load was created. So now let us go back to the topology view and see what's happening to our pods, right? So now there is no load on the application, so it will start slowly scaling back from 3 to 1. So while I wait for this to happen, probably I can do, like we can see the benchmark comparison here, which we were talking. So what I've done is just to make it handy, I've taken the Apache Bench results. I've done a comparison here without HPA. What is my response time? So with HPA during the transient state when the pods are getting sped, what is the response? What do the stats look like? And once it is reached a steady state, how the stats are going to look like. Okay, so just a side-by-side comparison. So more or less, all of the things remain same, but you can see that the time taken for test is 173 seconds with single pod, that is without HPA settings, which I done the test sometime earlier. We don't see that in the demo in the interest of time. With the HPA in the transient state, it is about 66 seconds, right? It's already 1/3. And once it is in steady state, it is just 25 seconds. It's again 1/3 of that time. So if you see from 173 to 25 with auto scaling, it is basically almost 900%. Okay, so 3 times and 3 times, so 900% of the response time benefit to the end user, right? So with high load, end user is not experiencing any delay or any bottleneck. He's still seeing a great performance, and just 2.5 milliseconds he is going to this is the per request, that is the total time, what you see in the column 8 and row 8, and what you see in the row 16 here is the milliseconds per request, right? It was 17 milliseconds because 100 concurrent requests, so averaged out, and 6 milliseconds per request, and here it is just 2.5 milliseconds. It's just like that. I mean, there's no delay at all. So it's so instantaneous response from the application. Okay, so that is the benefit. While we know that the auto scaling brings the benefit of conserving the resources and reducing your cloud cost when the resources are not utilized, and all that benefit, at the same time we have to greatly appreciate the end user experience and the elasticity that it brings to the end user, that there is absolutely no bottleneck and the application is highly scalable, and the response time is just good, and you get your application at 5-star app deployed on the OpenShift platform due to this horizontal pod auto scaling, and it is completely controlled and by the cluster configuration as we saw just before now. Okay, so this kind of concludes. I'm just waiting. I mean, it will take seconds just to meet this threshold time. Yep, you can see here. So now that there is no load for some time, and it started auto scaling from 3 back to 1 pod. I just refresh the screen. When it comes back, it should be 1 again. Yep, it's again just 1 pod is running. The 2 pods have been killed because there is no load again, right? Yeah, so this concludes the demo, and this is how in a very simple way we demonstrated that how HPA can be set on OpenShift. So try your applications and deploy on OpenShift, and then get these benefits of real horizontal pod auto scaling for your application on this container orchestration platform. Okay, thank you very much for watching the demo.